So let's look at the derivation of the mirror formula in bracket 1 out of f equaling to 1 out of u plus 1 out of v. We'll look at the derivation of that idea there, and we shall begin with the concave mirror, and in the concave mirror we shall begin with the point object. Is that okay? So we are going to look at how do we derive what we are calling mirror formula given by that expression. And we're saying basically we shall first start by deriving for concave mirror, and under concave mirror we shall look at the point object. And then I will say consider a point object or along the principal axis of the concave mirror forming an image I as shown below. So if I have this as my concave mirror, and then I have that, if I have an object here, and then the ray comes and then reflected, okay, and then I have this one being reflected along with the same path. If as a result my image I is here, this one here this angle here, because if this comes and get reflected, this angle is theta, and this will be theta as a result of the laws of reflection. This one can be alpha, this one can be gamma, this one can be beta. And then this is the center of curvature, and then this is the pole, okay? And then I can have this, as the image distance v. I can have this as the radius of curvature, and then I can have this as the object distance, okay? And then I can also have this as my height h as well. So we can now say from the diagram okay, from this diagram here, what is very true that is that angle OXC is equal to angle CXI, and the logic behind that is laws of reflection. Law of reflection. That the angle of incidence is equal to the angle of reflection, because the ray that passes through the set of curvature is a normal, therefore it is acting as a normal to divide these two. Therefore this will be theta equal to theta. And then we can also say for triangle XOC, we can now say that for that triangle, what is very true is that what is for this triangle here, theta plus gamma is equaling to theta plus alpha. Is theta plus alpha. Theta plus alpha is equaling to gamma. That is the sum of two interior angles is equaling to one exterior angle. And then if we also come and say for triangle XCI, we shall also say theta plus gamma is equaling to beta. Is that okay? And I can say theta equaling to beta minus gamma. And then this can be equation star. And then substituting equation star in equation 1. Isn't it? So we can now say if you are putting here, it will be beta minus gamma acting for theta plus alpha is equaling to gamma. And then beta plus alpha, if this comes the other side, it becomes twice gamma. This is equation 2. Is that okay? And now we can also say from these very triangles, what is very true is that I can say for x close to the principal axis, we can say xp is approximately a straight line. And if we look at this point of incidence here being close here, if it was close here, we would take xp as a straight line, in that we could look at it like something just like that. That is, if it was something like, if it was incident maybe from here up to here, and then you'd realize that this one will approximately be taken as a straight line. But we're just exaggerating for the purpose of getting that concept. So we can now also say from this very triangle here, tan alpha is the same as opposite over adjacent, which is u. And then it is also true that tan gamma is opposite h out of r. And then you can also say tan beta is opposite of adjacent v. And then we can say for smaller angles measured in radian, okay? If you look at small angles measured in radian, tan alpha will approximate to alpha, and this will be equal to h out of u. And then tan gamma will approximate to gamma, and that will be equal to h out of r. And then maybe tan beta will approximate to beta, and that will be equivalent to h out of b. Upon substitution in equation 2 gives, it will give beta is h out of v plus alpha is h out of u, should be equal to twice gamma, but gamma here is h out of r. If you multiply, this is supposed to be h. If you multiply throughout by 1 out of h, we should now multiply here by 1 out of h, 1 out of h, 1 out of h, 1 out of h. You'll say it is 1 out of v plus 1 out of u equaling to 2 out of r. And then you know here that but r equaling to twice f. We can say 1 out of v plus 1 out of u equaling to 2 out of 2f. So here we can say 1 out of u plus 1 out of v is equaling to 1 out of f. And that is basically our expression, which can be arranged as 1 out of u plus c. That 1 out of f equal to 1 out of u plus 1 out of v, which is the mirror formula we are supposed to derive. So don't forget the step we followed, our diagram, the simple geometry we are following from our triangles in deriving all this one here to reach this point for consideration of our point object. Very important, the assumption means. Without the assumption, nothing is right. Therefore, be good to consider the assumption. So let's meet in the next part.